Hello again, math students. We're going to have one more day of new volume stuff. And when we're taking a look at the work today, we're going to be working with things called composite or compound figures, they're sometimes called. It just means that we're going to have more than one shape that's being put together. So we're going to have to figure out which shapes are being used, find the volume of each of those shapes or figures, and then we're going to either add or sometimes we subtract to get our final answer. So for this problem, we have a rectangular prism, a box, and it takes out that middle part of it, also a rectangular prism, right? I know that we haven't worked on this volume formula in this class, but you know how to find the volume of a rectangular prism. For the bigger one, we're going to have that the volume is going to be length times width times height. That's the same formula that we use for the smaller one, but I want to keep track of which shape I'm working with. So in this one, the length and the width and the height, this 5 and this 5 and this 8, those are our three dimensions that we're worried about. And I don't really care which one goes where. So 5 times 5 times 8. 5 times 5, you know that's 25, and 25 times 8 is going to give me 200. For the smaller prism, this is 2 by 2, and they didn't give us a length on this one, but it's going all the way through the entire shape, which means that it will also use that same 8 centimeters. So the volume is going to be length times width times height. So 2 times 2 times 8, which would be 4 times 8 is 32. Because they're taking that smaller one out of the bigger one, this is a subtraction problem. So I would have 200 minus the 32, and that's going to give me 168. The label for this would be cubic centimeters. Notice no decimals, no rounding, because we didn't have pi in this particular problem. Now, for this one, I have a cone with, really it's just a hemisphere on the top. So for this one, they both have exactly the same radius. They give me the diameter here, which is 12 centimeters, but that means that the radius is going to be 6 centimeters. The cone has a height. Remember, the hemisphere or a sphere really only has the one measurement. So in this one, I'm going to have that let's do the cone first. That formula is 1/3 pi r squared h. The radius we know is 6, and the height in this case is 12. So you can certainly go ahead and simplify like the 1/3 with the 12. Remember, you can't do it with the 6, but you can do that if you want to, or you're going to be using your calculator anyway. 6 squared is going to be 36 times 12 times pi, and then we're going to take that whole answer and divide by 3. That's going to give me, on these answers, I believe we're going to 2 decimal places, so 452.39, this would round to. I hope that you're doing this on your calculator as well. For the hemisphere, we didn't have a specific formula for this. However, I have a feeling that this is going to make sense to you. If I say that the volume is going to be 1/2 times 4/3 pi r cubed. The 4/3 pi r cubed, we know that's the volume for a sphere. For a hemisphere, it's going to be half that. If you wanted to just find the full sphere and then divide by 2 at the end, that's fine. I worry because sometimes students get so happy that they're finished with the problem, they forget to do that last step, which is dividing by 2. So I like to write that right into the formula if I can. So again, in this case, you can certainly multiply those 2 fractions together, or you can just leave them the way that they are. I'm going to substitute in that my radius was 6 on this. And 6 cubed we've used a couple of times now. 6 to the 3rd power is 216. So the way that I just do my normal sphere is I would get that 216 times 4 divided by 3 and then times pi. there's my full sphere answer, and then I would just divide by 2 or multiply by a half to get the final answer on this one. So for my hemisphere, I'm going to get 452.39 when I round that. These happen to be the same answers. And I knew that they would be because of kind of how these numbers work out. When I do if I would have gone through and done some simplifying, some canceling, you'd see that we would get the exact same answer with our pi in each of these. Not that you needed to do that. Now, to get the final answer, because that hemisphere is being added to the cone, I would have 452.39 plus another one of those, or just times 2, which is going to give me, so my total volume is going to be 452.39, gives me 904.78, and this is in cubic centimeters. This answer is if you had used 3.14, which I tend to not do very often, and I realized that I forgot to change it on this answer key. I'd be okay with either answer. I prefer the pi button. It's more accurate. Not that there's a huge difference in this, but it does make a little bit of a difference. Okay, this one is actually a rectangular prism, and I'm going to take out the cone that's in there. It looks like there's extra measurements in here. This 5 right here, we're going to talk about in just a second, but let's just start by talking about the prism, like the box, right? That is length times width times height. Again, that's an old formula, but the 5 and the 5 and the 7, those are my 3 dimensions that I need. So 5 times 5 times 7, that's 25 times 7 would give me 175. Then for the cone, volume is 1/3 pi r squared h. The r, we have to be careful with here because they give me the full diameter of this cone, which is 3 centimeters. So the radius is going to be 1.5 centimeters. And the height in here, that's where that 5 comes from. The cone doesn't go all the way down to the bottom of the prism. The cone is only 5 centimeters tall, so it doesn't touch the bottom. So we're going to have 1/3 pi times 1.5 squared times 5. So 1.5 squared is 2.25 times 5 times pi, and then divide by 3. 11.78. Now, because I'm taking the cone out of the prism, this is a subtraction. So I'm going to have 175 minus 11.78. Gives me 163.22, and that would be in cubic centimeters. This one, some buildings actually look like this with that rounded kind of a top. This is a prism on the bottom, and I know that that picture is a little bit skewed. It doesn't look quite perfect, but the bottom is just basically a box, and the top is a half of a cylinder. They cut through the center of the cylinder from one base to the other base. So we still have only a half a cylinder on this one. For the prism on the bottom, I'm just going to actually do it right in the shape. That's going to be length times width times height. So I'm going to have 12 by 8 by 25. So that will be 12 times 8 times 25 is going to be 2,400 cubic feet. Then for the half cylinder, I would have that the volume of a regular cylinder is pi r squared h. I'm just gonna put that 1/2 out in front right away. I know I only have half of the cylinder anyway. That way I won't forget about dividing by 2 at the end. So I've got 1/2 pi. The radius is halfway across. Now I have the full diameter right here would be 12 feet. So the radius is going to be 6 feet. And the height, the length from one base to the other base is the same as the other one, which was 25. So I'm going to have now 36, 6 squared is 36 times 25 times pi would be the full cylinder. Then I have to divide by 2 because I only have half a cylinder. So there's my half cylinder volume. And now I just need to add those two together, right? Instead of rewriting, let me just do this. We should have 3813.72 cubic feet. Now for this last problem, I have a cylinder and I'm taking a cone out of it. It's actually kind of a cool trick that I can show you at the end of this one. Because I have the diameter of 20 centimeters, that means that my radius for the cylinder and for the cone will be 10 centimeters. The height for both of them, 33 centimeters. So when I take my cylinder, volume is pi r squared h. So pi times 10 squared times 33. So 10 squared we know is 100 times 33 and then times pi. It's going to give me 10,367.26 when I round. For the cone, volume equals 1/3 pi r squared h. Now, almost the same formula, remember. When I substitute my numbers in here, the radius is 10, the height is 33. The only difference here is the 1/3. So since I already have my answer in my calculator from doing the cylinder, I could just take that and divide by 3 to get my cone volume, which is going to be 3455.75. And again, because the cone is being taken out of the cylinder, that means it's a subtraction. So I'm going to take the total volume of the cylinder and I'm going to subtract that 3455.75. So 10,367.26 minus 3455.75 gives me, and this is going to be in cubic centimeters. I've got 0.51 based on how I did my rounding. If you're off by 1/100th, I'm not too concerned about that. Now, here's the cool trick that I said. That cone was 1/3 of the cylinder. I'm really taking out 1/3 of the volume of the cylinder, which would leave 2/3 of that volume left. If I would take the total volume of the cylinder, which was that 10,367.26, and just multiply by 2/3, so either multiply by the fraction 2/3 or multiply by 2 and then divide by 3, I'm going to get the same answer as what I had. Taking that cone out is really just, again, taking out 1/3 and leaving 2/3 of it left. So today's worksheet is about composite or compound shapes. The answer key is in Schoology. Because there are multiple shapes, I can totally see how there might be some mistakes that happen early in a problem that can throw off the whole problem. Please check it with your answer key. Make sure that you let me know if you need any help with anything. And when you're done, take the knowledge check in Schoology. Let me know if you need any help.